Okay, now we're going to go over your absolute dating questions in your review book. So we're on page 290. Question number 37. Base your answers to questions 37 through 39 on the following graph, which shows the radioactive decay of uranium-238. 37. The half-life of uranium-238, as shown in this graph, is closest to. All right, so if we originally have 100, half of 100 is 50. Go to the 50, read over until you intersect the line, and then read down. So I am just shy of 5 billion. So my answer is going to be 4.5 billion years. Question 38. Because of the half-life nature of the decay process, uranium-238 will theoretically... Now, every time you take a half, so 50, then 25, then 12.5, then 6.25, and you're always constantly taking half, so it will continue to decay indefinitely. It just gets smaller and smaller and smaller to the point where it's not useful, but it never totally decays. 39. Some uranium is obtained from an intrusive granite formation. It is then analyzed and found to contain approximately 1 gram of lead-206 to every 3 grams of uranium-238. Approximately how many billions of years old is the granite? Now, if it had a half-life, you would have 2 lead to 2 uranium. So you're halfway to your half-life, because you have 1 of your stable lead and 3/4 of it is still radioactive. So if I'm looking at uranium, its half-life is 4.5. So half of 4.5 would be 2.25 billion years. So I'm halfway to a half-life, so 2.25 billion years. So your answer has got to be 2 billion years. Base your answers to questions 40 and 41 on the following diagrams. Number 40, which curve represents the expected decay rate of uranium-238 if its temperature was raised almost to the melting point? Remember, temperature, pressure, the amount that you start with, time, has no effect on half-life itself. So uranium, you're going to keep the same curve. You're losing exponentially, so your answer for 40 is number 2. 41. If the decay curve for the element carbon-14 were plotted, which diagram shows the general shape that the curve would be? That too is answer 2. It is decreasing exponentially. 42. The half-life of a particular radioactive substance, number 4, is independent of mass, temperature, and pressure. The whole idea, if the mass changes, if you change temperature, if pressure changes, if they change too, then we couldn't use radioactive decay as a form of absolute dating. So it has absolutely no effect, so your answer is number 4. 43. If a specimen of a given radioactive substance is reduced in size, its half-life, 3, remains the same. As I said already, temperature, pressure, how much you start with, has no effect. Number 44. Which radioactive substance shown in the following graph has the longest half-life? If you're looking at it, you haven't even gotten close to having a half-life on D. So the more gentle slope, the longer the half-life. So your answer is going to be D. Question 45. Why is carbon-14 usually not used accurately? Let me try that again. Why is carbon-14 usually not used to accurately date objects more than 50,000 years old? Well, since this question has been posted, it's actually now 70,000 years with technology. All right, the whole idea is after 70,000 years, not enough of carbon-14 is remaining. You're down to the point where every time you have a half-life, it's half of what you had the half-life before. So you get to the point where it's like 0.00 something. Remember, half-life, you never fully get rid of it. It gets to the point where it's not useful any longer. And after 70,000 years, not enough carbon-14 left. So your answer is going to be 1. Carbon-14 has a relatively short half-life, and 2, little carbon-14 is left after 50,000 years. 46. Carbon-14 is often used to date fossils from the Holocene epoch. Why would carbon-14 be less useful in dating the Ordovician fossils? If you look at your reference table, Ordovician, you're looking at 444 to 488 million years ago. Remember, we just said 70,000 years is you're going to get from carbon-14. So the half-life is too short and not enough carbon-14 remaining. Okay, flip it on over to page 295, question number 47. The following diagram represents a cross-section of the Earth's crust. The symbols in the diagram indicate the location on a horizontal surface of certain fossils that formed during the Carboniferous period. For what purpose would the fossil information on the map be most useful? If I'm looking at the map, they're telling me I have land fossils and I have marine fossils. With that, it's only going to help me to find where the location of the shoreline is for the Carboniferous period. So if I needed to, I'm going to draw the shoreline in. I did it already in the pink. I am separating my land plants and my land organisms from my marine organisms. The pink line represents my shoreline. Question 48. Shark and coral fossils are found in the rock record of certain land areas. What does this presence of these fossils indicate about those areas? Well, the only place where we find shark and coral nowadays is in water. So the assumption is back then it was the same thing. So your answer is going to be number 4. Were once covered by a shallow sea. Number 49. Approximately 3.5 billion years ago, photosynthetic organisms evolved. What dramatic change in the Earth's atmosphere resulted primarily from this event? Photosynthesis, the byproduct is oxygen. So eventually you got oxygen that was put into your air. That information also on your reference table. Page 8. If I'm looking here, oceanic oxygen produced by cyanobacteria combines with iron, forming iron oxide layers as in an ocean floor. Move up, oceanic oxygen begins to enter into the atmosphere. So photosynthetic organisms give me oxygen. Number 50. The changes observed in the fossil record from the Precambrian to the Cenozoic era best provide evidence of. You're looking at organic evolution. The whole idea, if I look here, remember these are my organisms that correspond to letters here. So if I'm looking, my A, my B to my C, my A to my B to my C over here, my trilobites, shows evolution. So we're going to go organic evolution. Number 51. Which statement is false? The statement that's false is 2 members of one species must be exactly alike. If you look at the person next to you, you are not identical to them. So you're not exactly alike. Number 52. The following diagram represents a site in western New York State. The remains of the mastodon were found in sediments from a swamp located above limestone bedrock. Fossils of the Paleozoic coral were discovered in the limestone beneath the swamp. Observations made at this site provide evidence that. Alright, so if I'm looking at coral again, remember, warm, shallow seas. My mastodon's got to be on land. So my answer is going to be the local climate and the environment have changed dramatically. So I went from warm, shallow seas to being land. So 52, answer number 1.